Hey guys, what's up? So today's little video, I've got something really awesome here. So as you can tell, we're looking at a server and we're going to be setting it up just a little bit today, putting in some hardware, and then next time we'll be booting it up and getting an OS and all that. But today we have this awesome server. So I'm super excited because we just have some awesome components to put in here. There's a little spoiler, well, major spoiler. We have some graphics cards to deal with today because we are finally going to be attempting to virtualize a graphics card. So this is a Radeon Pro V340. This is one of the original cards, the 32 gig variants of the card, not the V340Ls that have been flooding the eBay markets and stuff for super cheap. This is one of the original 32 gig cards. They're super rare, and actually I have the original hardware and the original server that this card would have been installed in to allow it to be virtualized into 32 different VMs at 1 gig, or depending how you want to do it. This is a Radeon Pro V340. It has dual, essentially Vega Frontier editions on it, so those are dual 16 gig Vega series cards. They're like Vega 56s, but with 32 gigs. And as you can see, there's two cards on the bottom, so 16 gigs of HBM2 each. And like I said, this is the original server. We even found the original power cable, which is super awesome because you just can't buy them anymore. And we have the risers, we have the server, and I even have the original OS and drivers that I got. So we hopefully will be able to virtualize this thing. But in today's video, we're just going to get this hardware set up so that we can start installing that and giving it a shot. So what we have here is a Cisco UCS C240M5. This is a 5th generation Cisco server. Originally designed to obviously run Cisco's UCS software and some kind of VMware and all that, but obviously I'm not running that because I don't believe in Cisco's licensing, nor does Cisco believe in me and would even let me purchase it anyways. So we'll be running a VMware on this later, but the server should work fine. This is the model, as you can see. We'll show the whole front and end, the finished server later, but this is the one with 8 2.5-inch bays in the front and 2 in the back right there, and then dual 750 watt power supplies. So anyways, let's start building out. The first thing we need to do, these are actually empty sockets. They have these nice copper heat sinks on them. We have our 80mm fans in the front, but obviously we need some CPUs in here, so we have dual sockets. LGA 3647 supports 1st and 2nd gen Xeon Scalables, and here we happen to have 2 1st and or 2nd gen Xeon Scalables. Well, these are just test CPUs. We'll be putting in better ones later, so we're gonna leave this weird thermal paste it came from, but yeah, so we'll leave with this on for now. It's enough. There's nothing on these coolers. They've been cleaned completely, but I don't really feel like cleaning these off, so this will work for now, and we'll put on better thermal material later when we replace the CPUs with much better ones down the line. So first things first, we'll get these in. These are Xeon Gold 6138s. They're the very basic 20-core 40-thread CPUs, very low clock speed, meant for high-density virtualization, just not exactly very fast virtual machines. We need much faster later, but for now, we're going to go ahead and do this now. Now that it's out of the plastic, you can see there's an orange triangle there and a giant triangle cut out there, which means this is the way the CPU goes on the cooler. CPU goes on the cooler first, unlike some other servers and consumer grade where the CPU goes in the socket. Nope, goes on the cooler, just like that. And that's not coming off. Although it is always worrying because, you know, we have 3,647 pins. One of them breaks, your thing could be a brick, so I'm gonna get these wires out the way. So let's get this dropped on there like that. Now, as you can see, we have these like star screws, torque screws here. Unfortunately, I don't have that kind of screwdriver on me. So, flathead. Because if you don't know, everything's a flathead. Except for this screw on screen now. That screw is not a flathead. That screw is a devil screw. Though I've only seen it on elevators, and thankfully I'm not an elevator guy, so go ahead and do it in order, kind of, and then put our actual mounting screws. 1 and 2 just hold the CPU cooler in. 3 and 4 actually provide the mounting pressure. So thankfully I also just happen to have the perfect size flathead. It's one of the very few flatheads like dedicated I have, and it happens to be the perfect size for doing these coolers, which I find hilarious. But these ones specifically are flathead. There we go. And we'll go ahead and do the next one real quick. One sec. Now, something I just noticed and thought I would share, because this is the nerd channel. The socket clearly has this like metal bracket, clearly has a gap, you know, right there if you can't see it, for something. And that is for Intel's OmniPath. Now, of course, it's a dead technology because Intel will never sell technology to other people or something like that. I don't know. Anyways, it was a physical gold finger, basically, that came off a CPU, like this one here. That's just graphically pasted on screen, where you would physically connect a cable to the CPU itself, and it would go to a NIC, like this one, but with a connector on it. And it would go to a 100 gig OmniPath connection that would allow you to a specific switch, with a fabric switch, and allow you to create a CPU fabric. It was super cool. I'm sad they killed it off because it would have been an awesome technology to play with. Technically, it might still work, but it really was just for the enterprise, and the switches probably don't even work without their fabric managers, if you can even buy one of those. So, yeah, I mean, there's newer fabrics, but that was always a cool one because the CPUs were literally physically connected to each other instead of having to go through all of this metal first before getting to an InfiniBand NIC or something and connecting. Anyways, thought that was really cool. I don't have one. I like to get one of those CPUs just because they're fun, and they still work as normal CPUs, but I don't have that yet. They cost money. Alright, we'll go ahead and get this CPU in real quick. Sorry, another aside. You'll notice this literally has like a screwdriver symbol on it, because you're meant to shove a screwdriver in to pop off the CPU to get it free of its bracket. It would be free if I had two hands, but you get the point. I thought that's very, very well done, Intel. And just like that, it's all in. So, obviously we have 24 DIMM slots here for RAM. We're not going to use all of it yet because, you know, RAM is kind of an issue. It's funny, I do actually have Cisco branded memory, about 2 terabytes of it to be exact. That showed off in a past video, but unfortunately it's currently in transit to me, so I don't have it with me at the moment. It's moving continents at the moment to go do some data center stuff, but for the moment we have kind of a crime, but we've got some Lenovo 16 gig 2933 actually, but I think it'll run at 2666 because these are first gen CPUs. But we have 4 16 gig sticks to make 64 gigs just for now, which will be enough to do some basic virtualization, which is all we need for now. This server is for HomeLab. It's not going in data center or anything. It's inefficient size-wise. I don't need that many graphics cards. I think I'll get a 1U graphics card server for the data center. That is not where that DIMM goes. Hold on. But here, quieter, larger servers are the king. And since it's running Xeon Scalables, it'll be a good analog for our Xeon Scalable servers that are in the data center. Although those are 1U servers that are much louder and can't run here like that NetApp storage appliance server. We have the NetApp 1U that's going in the data center. Too damn loud. Yeah. Alright, there we go. 64 gigs of RAM, nothing special. We'll put in a lot more later. I would like to point out real quick, this thing does have a 40 gig NIC in it, dual 40 gigs, so there's 80 gigs to it already, which is awesome. Alright, let's get our graphics card situation set up. And now our graphics card situation is set up. So, in our first riser, this thing takes 2 risers. We have this. Hold on, let's pop this metal out. Come on. There we go. So, these are PCIe, what look like 24X slots. Now, it's weird because as you can see, it says PCIe X8 on it. So, I don't know if there's a way to rewire it in the BIOS to make it 24X or something, and I don't know what was supposed to go in it. Maybe they just ran out of parts. I have no idea, because it's weird because it goes to dual 16Xs, so maybe they make a card that just has extra support like that, which is my best guess. So anyways, what we're going to do is we're going to go ahead and pop this in, just like so. So I'm kind of more focused on the card and getting it in than I am on anything else. So just like that, we have that in there. Close that. Come on. No, this doesn't want to cooperate fully. There we go. And we'll close our retention mechanism. Gives a little bit of extra support. It stops our card from falling into the board and exploding. Now, you may notice there's no power connectors on board or with the power supplies to go to the card. And that's because, yep, you guessed it, it comes off the riser right there. But that's a 10 pin. And this takes two 8 pins. So what do you need? The special cable that only comes with the Cisco branded cards like this one. This was originally a Cisco spare for this server, which is why I'm in the perfect situation to get this card working, hopefully. And it came with this cable. Now, thank God I didn't throw it away, because at the time I was like, I'll never have a Cisco server. Me when my Cisco server. Anyways, I found it in an old bin. I was super happy because you just can't buy this cable by itself anywhere, at least that I found. Only the 8-pin version for M10s and stuff. But anyways, that goes on there like that. And then connects to our graphics card. Sorry guys, my filmography is not great. I'm mostly focused on this. I've got one card and one cable, so. And just like that, it's in. And now it's super simple to get this riser in. We'll go ahead and pop that. I think this is E2. So 2 goes on the left, assuming this is the left. So we'll go into that slot. So let's see if we can do this one-handed. I'm believing this card is not meant to go on the bottom. One sec. Ah, much better. So yeah, as you can see, our card is there, yeah. You need room for airflow. Having this PCIe cover installed is super important. Hey, look, it's our hidden mini display port. It's super important for airflow so that air doesn't just go around the card entirely. It's forced to go through it. And just like that, that is installed. Okay, so as you can see, we're missing a riser here. And there it is. So let's get our next set up. So much like for that one, we are going to put a graphics card in this one because we don't need too much more network other than the 40 gigs, and we'll put in more later as we need it. This one, we have the slot in the middle empty for this. This is an NVIDIA Tesla P4. So it's basically a GTX 1080, but super cut down, same amount of cores, and 8 gigs of VRAM. But on this little card, meant for virtualization at low power. In case we can't get that working easily, maybe we could show off virtualization using this. Oh no. Well, that just looks kind of sad. But yeah, now it's in. I'm going to go ahead and put the riser in off cam because I'm tired of trying to almost breaking my things. I'm not buying another one of these, I swear. Alright, and just like that, our server's back together. As you can see, when it's all put together, it is a very kind of, I'm looking for a word, but smooth is all I can think of. You know, it's when I opened it at first, I was like, what the, you know, it's impossible to tell what you're looking at here. You know, you can tell you have, you know, 3 GPUs, 40 cores, you know, RAM you can't see. I had to put this on first and then put these back in because as you see, the GPU cable rests perfectly on top of it. I want to go ahead and assume it's going to get enough airflow, but we'll see if there's any problems. We'll know exactly what the issue is. So, just like that, our server's put together. Let's put the lid on and see what it looks like. Yep, that's a server. Anyways, last thing we do before we end this little video off is, as you can see, like I said, there's our front plate, and actually, we'll put that on last, but we only have 8 bays. It did come with blanks, but I just ordered 8 of these Cisco branded 1.2 terabyte SAS drives. Only, they're SAS, as you can see. I only ordered them because these trays by themselves are like 10 to 20 bucks. The drives were about 10 bucks, so I was like, well, might as well get some free drives with it. And I only needed 2 for the back for SSDs, but might as well put the other 6 drives I have in the front here. Oh, the way they're written, it seems like it's meant to go in this way. And we'll put in 2 for now, just so we have some storage before we end this off. So yeah, they're written as if they go like that. Very nice. Once we have them all filled out, it'll look super cool. And then last step, servers don't often come with these, so I always found it nice that it did. We get our front bezel on now. This definitely belonged to someone before me, so yeah, I guess it was the RAID M5. So it was a server that had a RAID. Not sure what it was originally for. You can see it's the UCS C240. Anyways, now we have the server. So next time we see the server, we'll hopefully be in software, putting in, well, hardware to put in the rest of the drives, and in software looking at virtualization. So hope you guys kind of enjoyed. If you have any ideas what I can do with the server or would like to see something else, let me know. Thanks so much for watching. I love you guys, and I'll see you in the next one. Peace.